Physics 101 Dynamics homework number 9. This one's a little tricky. A few of the parts are a little tricky. It helps to draw a diagram, a free body diagram. So, for example, the first one, we have a force down, we have a force up for scenario A. The force down is equal to the force of gravity, which is equal to the mass times the acceleration due to the gravity. The force up is the tension. And since it's not accelerating, the net force is 0. So we know that the relationship between those two forces, we know it. Or you should know. The second one gets a little more complicated. We have more forces. We have, again, the downward gravitational force equals mg. We have a tension force this way, and then we have the tension force, there's my undo. Then we have a tension force kind of going up like this. Once again, not accelerating, so the net force has to be 0. And in order to, break this down, I need to look at the components of that tension force. There's a X component to the tension force and a Y component to the tension force. And if it's not accelerating, again, the forces up have to equal the forces down, the forces right have to equal the forces left. So that should show you the relationship between mg there on the bottom, mg, and the tension force. That's the hypotenuse of those two components. A few that you're going to want to pay close attention to. Scenario C, not accelerating. So the net force on each of those masses is 0. Scenario D, also not accelerating. Scenario E, it is accelerating. We have an inward acceleration. But it turns out to be similar in form to scenario B, because we still have our tension force going up at that angle. We still have our gravitational force coming straight down. And once you draw the diagram, you can look at the forces and see how they relate. That should help you make sense of these. Scenario F and scenario I are accelerating. So when we look at our forces, they're going to be unbalanced because we have a bigger mass here, a smaller mass there, which means it's going to be rotating as it accelerates in the direction of the larger mass. So if it is accelerating, I'm going to erase that. Let's put on there. If it's accelerating this way, if the big M is accelerating that way, that means the net force is going to be down. All right? The downward force is mg. The upward force is the tension. With that information, you should be able to figure out the relationship between T and mg. Similarly, in I, it's going to be accelerating towards the larger mass. The larger mass is going to fall and the smaller mass is going to go up. So it's going to, this smaller mass, the bottom one right here, is going to be accelerating upwards. The upward force is tension, the downward force is mg. Again, with that information, you should be able to determine the relationship between T and mg, whether it's greater than, equal to, or less than. Scenario D, I'm going to leave to you. I think you can figure that out. Scenario G, I'm going to leave to you. I think you can figure that one out as well. All right. Here, the one that's going around in the circle. Oh, I'm erasing again. The one that's going around in the circle, like this. Also accelerating using something called centripetal acceleration. And its acceleration is going to be towards the middle of the circle. So you'll just have to take my word for this because we're going to cover it in an upcoming chapter. It is going to feel a net acceleration towards the middle of the circle. The forces are the tension and the gravitational force, which I can't draw because I've got something in my way here. We have a gravitational force down. So again, given that information, you should be able to figure out the relationship between tension and mg.